He seemed really happy about the prospect of being known as Drew.
Andrew?
Calling him Drew now?
Mm-hmm. Yeah, I can hear you now.
Can you see the screen?
Yeah, I can see the screen.
Okay.
I heard your name's Drew. Is this true?
Henceforth.
Now you see the PowerPoint slide there?
Yeah, I see it.
Okay, gotcha. Great. Let's get started. This is the first seminar for the automation for QA. Today I'm going to introduce like why we need automation and yeah, and the necessity of automation for each Scrum team. That's kind of the first session that we are focused on. We're not gonna go deep into the detail yet today. So it's kind of introduction session since it's a kind of first one. So do I have to know what the automation is and even how is the topic for today? Even during lunchtime, do we have to know this while we're eating something? Is that important? That's the topic for today. Yeah. Eric, do you think it's that important?
Yeah. No, I'm eating.
Yeah. Do you think so?
Yeah.
Yeah. Why do you think so?
Oh, why we know, like, why we have to know automation?
Yeah.
Our testing easier as QA. Well, not easier, but it lets us automate the boring stuff, to be honest. And then for the how, I mean, if we're going to help create them, we should know how to make them.
Okay. What about Mike? Do you think it's important?
I think it's important to be able to automate the manually intensive components of stuff, especially for web-facing things that really aren't automated right now.
Mm-hmm.
So boring stuff.
Yeah. Manually intensive.
And chat.
Yes, definitely about regression.
Regression, yeah.
Yeah, a lot of the items that typically aren't seen for a sporadic behavior.
Yeah. So people feel that it's important and we need to know about it. So that's why we gather together even during the lunchtime. Let's go to the next slide. So the term automation. What do you guys think of the concept of the automation? And definitely have a benefit and a disadvantage. So Mike, what do you think of benefit for the automation and the disadvantage for this?
Benefit is larger scope of testing that wouldn't be available otherwise. Disadvantages, there's a definite cost to automating, especially with something that's changing frequently. And you have to update your scripts and have to continuously modify.
Mm-hmm. The cost saving.
Yeah.
Sometimes it's beneficial, but if it's kind of frequent update, then it's kind of cost more than you expected. Okay, that's a good point. And Ted?
What's the point? Also, large cost.
The cost.
But disadvantage, probably not going to get a lot of the manual or visual testing. It's more for things they can validate, create data and then validate that data output expected results. Not a visual or disadvantage or something.
Mm-hmm. You can do visual testing, but it's more difficult.
Correct. And is that
right?
I know with some of the stuff that it was somebody's job to go through a whole bunch of screenshots. Like, I would hate my life if that was my job.
Yeah, So we have to listen to the Eric too.
Oh, well, for benefit, again, you don't have to do boring test cases. The only real disadvantage that I always run into with automation is that it's really hard to set up like a production automation environment. There's always a lot of tools we have to create, and it's tough getting close. Well, not close, but closer to the production environment. So sometimes we get false positives with the setups.
Right. So definitely it has a benefit, also the disadvantage, but we still need it. Why we need it? Because some works which is very repetitive when they're not regarding the insight. The automation can replace those efforts. For example, like regression tests, we have to keep doing it, but the same thing, sometimes tedious, sometimes take a lot of time. We can replace that. The machines can replace our efforts. Also, the sanity test or our systems test. Sometimes a customer escalated defect reproduction. We know how to make a the script quickly, then we can repro it very quickly. Then run it, and sometimes the reliability, performances, we make a script quickly, then it's very efficient. So that's the automation. It has a good part, sometimes bad part, but we still need it. In contrast to the automation, the manual test. What do you think about the manual test, Mike? Your idea.
It is very manual. It's time intensive, and some of the stuff, it can take weeks to be able to test something that can be automated to run like very quickly. On the other hand, there's some stuff that has to be manually tested because automation, the act of automating the test and injecting test hooks into it actually modifies it to the point that it doesn't represent real world behavior.
Mm-hmm.
I know we've run into that frequently with hardware stuff where
I feel like you have a very bad connotation for the manual test, right?
Because it's a QA.
No, I think that manual test is something that's kind of necessary, especially depending on how hardware oriented it is. It's just something that has definite cost and time, and you can only really run a full manual regression set like once every sprint or longer than that. Otherwise, it just takes too long.
Okay.
On top of that, also manual testing requires more resources.
Right.
So if you're doing load testing, you actually need more systems, more parts, more actually performing tests for doing regression sets. But again, it is, have the advantage of having the physical connection with the rest itself, which you don't have with automation.
Right.
Additional problems.
Right. So, Eric, so don't you think the manual test is not necessary anymore if automation covers everything?
No. Well, that is a different question, but no, because for manual testing, even though we can have all these automation tools, right? But they always do exactly the same thing. Where in manual testing, we can see human error and stuff like that, and how people are going to react to issues and doing stuff their own way in ad hoc testing, which you don't get with manual or with automation testing. So we still need manual testing.
Right.
But it cuts down on the resources you do need for manual testing.
So
another
yeah.
Manual testing also helps basically determine what we need for automation. Something it's possible. So it helps us develop our automation as well. So even though we can do a lot with automation, we still need the manual piece to kind of like a grooming or vetting to basically improve on automation.
Exactly.
So they go hand in hand as well. Just one together.
Exactly. So if automation covers our full test cases, suppose this is done successfully, but we still need the manual testing. Why? We need the insight. We need the QA's insight, like exploratory test. That kind of test on your screen is kind of test that needs your creativity and insight. So we still need the manual test. So, can you read the screen, Eric, please?
You want to read it?
Yeah.
We can delegate the jobs which are repetitive and not requiring insight.
Yeah. That's why we need automation. Something that is very tedious and doesn't need an insight, we delegate the machines to do it. So we need to talk to the machines in order to let the machine do it. That's why you are here. Andrew, are you there?
Yeah, I'm still here.
Okay. So you clearly listen to the what your peer said?
Yeah, I listened.
Right. So let's think about driving a car. Driving a car is a job you guys are doing every morning or when you go back home. But if somebody make the car, so people can drive the car easily because someone made the car. But driver needs to know the mechanism inside the car, something like an engine stuff. Is it, Andrew? Thomas?
Yeah, I'm here.
Yeah. Do you think you need to know the mechanism inside the car in order to drive a car?
No.
Why not?
Because the engineers are the ones that made it to where the people can drive it without having to know how to build one.
Yeah, exactly. In order to drive a car, you don't have to know the mechanism and algorithm inside the car. That's how you drive the car.
Well, I think in order to drive a car, yes, but in order to operate a car, you need to know the car's fuel, you know what kind of fuel, you know how often it needs to be fueled, how much oil you put into it. These are the operators or items.
You need a user manual.
Yes. It's not just get in the car and go and, you know, you can drive forever.
You've never been married, have you?
Oh, but
yeah, so the drivers sometimes need to maintain the car in order to let the cars well. That's another work the drivers need to do. So that's what I'm saying. You don't have to know what's inside. Just like very complicated mechanism in the car. Something that we don't have to know. I don't know what it is inside, but I can drive a car still. So can you read the to drive a car should be easy on that part, Andrew, Thomas, please?
Yeah, it says to drive a car should be easy since it's indispensable transportation tool for a human in modern society. Let me keep going.
Yeah.
So everyone can drive a car in the street once you get the license. Designer and practitioner is supposed to be distinguished.
Yeah. So somebody made a car, and somebody needs to drive a car. So it needs to be distinguished. So keep reading this, Andrew, please.
The goal for this seminar series are for you to get the driving license rather than being a mechanical engineer.
Yeah. It's supposed to be easy. So you don't have to know everything about the automation. You just need to know how to drive a car and how to maintain the car. as well. So we have a little bit of left today. So, Mike, could you read that, please? Suppose.
Suppose you have a driver license and your own car makes specific scenarios for go to VGT office from home driving a car. Step 1, press the unlock button and remote car key. Check if car is unlocked.
Yeah.
Step 2.
Yeah. So could you fill out the form, the step 2 through the end of the steps that you drive a car from home to the office? Chad, what is the next step is going to be?
Open up the car door. So long as car door is unlocked.
Yeah. So
Sit down
check
into
if
the car.
door is
Very
open.
specific, or
Yeah.
I can go.
Check if the door is open after you open the car door.
Yeah.
What is the next step? Eric?
Get into the car.
Okay.
Sit in it.
And check what?
There's an important place on your seat. Yeah, but you have a seat
Yeah.
to sit in.
Check if there is a seat, and you sit down on the seat. Now you sit on the car. What is the next step, Andrew? Thomas?
Now that you're inside the car
Yeah.
and you've checked to make sure you're inside the car,
Okay.
then probably shut car door and check that car door is shut.
Okay. Car door is shut now. Okay. Then what is the next step?
Turn on the engine or insert key into ignition.
And insert the key.
Oh,
And
that's a step. The next one would be turn it on.
Turn it on. Then how to verify the car's turned on?
Verify any sort of warning dials and verify that car has turned on.
So you hear the sound too, right? Engine sound.
Mm-hmm.
You multimedia of your body catch if the car is turned on, right? So what is the next step, Chad?
Well, I would put my seatbelt on.
Huh?
I would put my seatbelt on.
Seatbelt on for the safety.
Yep.
How to check if your seatbelt is on or not? If it's working fine or
I
not?
would identify the seatbelt. I would then reach for the seatbelt, put the seatbelt over, put the seatbelt into the latch, tug on it to make sure that it is properly secure.
Okay.
Step complete.
All right.
Any audible signals? Chad, you're the safest person.
Yeah. Yeah, that's a good point. If the seatbelt is not worn in the car, what if the errors happen? What if defect happens? If the car is not going to well to the VGT office while you are driving a car, and your body is hurt, just like that. The programming doesn't going well, then somebody needs to hurt. That's not good. That's a good point. And then, what is the next step?
Well, this all kind of depends on your orientation of the car. Because if you're forward, you just check, put it in reverse.
That could be a check. You could check to see.
Or you check your mirrors or check your surrounding areas. And then the check would be that there's nothing around you. So you
Well, no, you could say check to see if car is facing toward street. If car is facing toward
paths.
yeah. Wait until you actually start driving.
Yeah, I would check to see what I have to do next. Basically, like around me, like car orientation.
Okay, Andrew, next.
Once we have our orientation, that should lead us to the direction. So start or press gas pedal and orient steering wheel towards direction.
Yeah, put in drive, bro.
Or reverse, depending on what.
Okay, we're in park. Sorry, change gears into drive.
Standard. I can't drive.
Okay.
Yeah.
Okay, we drive the car now. And suppose we are in front of the VGT office. What do you guys need to do, Mike?
We're in front of the VGT office. Signal for a right turn into VGT office.
The other way.
I go left. I go left.
I'm just joking.
We're seeing it from mine, so yeah, signal for right turn and then turn right into the office.
You go look for the cars.
Chad is the same thing. The same person all the time.
Okay, you prop the
I
car.
get the point.
You prop the car. Suppose you prop the car in the parking lot. What is the next step, Chad?
The car's in the parking lot.
Yeah, you're in the parking lot.
Restrooms as you're driving slow.
Oh my God.
Okay. Yeah, very cautious. That's good. Yeah.
And depending on who it is, you just speed up or slow down.
Proceed to the next parking spot
Okay.
available.
Yeah.
Well, into parking spot
Uh-huh.
by either going pulling invitation,
Yeah.
the car, you have to reverse
Yeah.
forward.
Uh-huh.
Once car is
Yeah.
in position, stop car.
Yeah. The car stop. What is the next step? Car stop.
Is it in park yet?
Car stop.
You would put in park?
Yeah.
Right. Then you would turn the key off.
Off. Yeah.
And I would check because all of my needles and dials would go down. And I
And
wouldn't
then.
hear it anymore.
And then what?
Then I would pull the key out of the ignition.
Uh-huh. And then what?
And then I would put the key in my pocket.
Uh-huh.
And then I would take my seatbelt off,
Uh-huh.
since it's been buckled and checked.
Uh-huh.
And then I would open the door.
Uh-huh.
And I'd get out of the car.
Uh-huh.
And I would close the door. And I'd lock the car.
Yeah, so it's done. It's done, right? So you made a kind of scenario of automation now. But that's your own words. But you need to talk to the machines if you want to let the machines do what you want it to do. The next lab. Can you read, Andrew, please? Lab 2.
Yes. So now you're rich enough to buy a very smart robot, which has been pretty well trained for driving a car for you. Can you delegate it to go to the VGT office from home driving a car? Please write the pseudocode for this. Lab, scenario. Let machines understand what I'm saying. Okay, yeah. You could read the rest.
Something like that. So car key is the kind of object, and unlock is kind of behavior. Unlock button is kind of property. So using this kind of stuff, please make down the pseudocode, just what you have done so far. Write down the code on your sheet right now.
Good.
It's gonna be like 5 minutes. If you need more time, let me know. Are you writing down, Andrew, there?
Yeah, I'm writing it down.
Okay.
Yeah.
Need more paper?
How detailed do you want to go? I mean, there's a lot of actions to tell a robot to.
For the record,
This one is probably too complicated to actually automate.
For drive, I just put robot.drive.
Yeah,
That's it.
that's
And it gets the VGT.
Robot that
I
drive.
think it's pretty in depth just opening up the door. So.
Well, after hearing your safety manual about putting on the seatbelt, I feel like that's like a 20-step process.
Well, I mean,
Again,
at a certain point, this is probably too complicated of an example to really automate and for this.
that'll have to be all three conditions to determine you don't know what type of car is it manual, standard, or is it automatic standard. I know you're gonna sigh.
All
Hey, I
those
already
details
did.
are abstracted away for you.
That's why this is a very, very complicated example to.
Maybe make a peanut butter and jelly sandwich.
Yeah, so that's my typical automation example. Yeah.
You have minimum number of items. You know what your end goal is. There isn't like a whole set of moving parts or complex operation. That's
I don't think that you're being judged on whether or not you get all of the Google car criteria.
well, it's again though you're trying to determine or write pseudocode for automating tests. So in order to do that, you need to know all the different scenarios that you want to automate.
Yeah.
So think about that. What type of car do you have? What type of key do you have? Are you actually putting the key into the car and unlocking it? Are you pressing the button? Where's the handle?
You guys make things so complicated.
Well, so to be fair, you could. There are a wide scope of stuff that you could do, but for this example, it could just be there is a car, and you're locating the car.
Okay.
I mean, that's kind of like the car is your server. There's a multitude of servers out there, but you're passing it a specific server.
Mhm.
Or a specific car as the parameter. So locate car.
Yeah.
And if you only have automatic as your cars that you have, then you wouldn't need to deal with.
Okay. So that's a precondition that we need to identify. Car is automatic.
No, you're not writing a test case.
I know, but you need to know what you're writing for. Because if it's standard, then you have different ways of.
You just have methods. This is like it's
Yeah,
like,
but
go.
so
It doesn't matter. Put it in gear. It doesn't matter. Like
that
just
would be
abstract it
a
all out.
different.
It's in the method. You just need the
Yeah.
general name.
Well, that would be a different test.
Almost time's up.
That's the condition, yeah.
Yeah.
Open door, enter car, close door.
1 minute.
That's it.
Finish it up within 1 minute, please.
I have just have to go. So I made each one.
Did you make sure that the temperature control was set?
I didn't get that far. I'm still on opening the door.
I have robot.park.
Right. I have robot.drive. Like that's all.
Well, so the robot.drive is actually way too complicated for us to try to.
Give me 10 minutes, Mike. I'll figure it out right now.
How many years has Google been working on it?
Yeah, 1, 2.
They don't have a robot. They don't have a super smart robot. They just have a car, sensors and
A
cameras.
lot of cameras.
What's going on there, Andrew? You finish it up?
What are super smart robots?
Yeah, generally. I tried to keep it somewhat detailed, but somewhat generic too. And my car's automatic, so.
Okay. Okay, then looks like everyone finishing the pseudocode. Then Eric, could you show us your masterpiece?
Like show it or like this is it?
Explain.
So I just had the robot do all the actions, and then I just had check. So I had like robot, like I started robot.unlock car, and then I had the check if car.door lock equals to unlock. And the next one, same thing, like robot.open car door, and then you check the car property for door to see if it's open, and then get in car, and then you check the car property has seat, make sure that's true, and then close door, and then you check the door property that it's closed, and then put seatbelt on, and then check the seatbelt property for clicked because I couldn't think of a good property. To like make it equal to, like it wouldn't be true, I guess. So I don't know. And then put like all the stuff we just did, and that's basically my whole setup. And then basically you get in, you drive, put the key in, all that stuff, and then you get to VGT and you do pretty much the exact opposite to get out.
Yeah. Looking at your writing, it looks almost like a code, not like a human language, but looks like a code. Looks like a machine can understand what you're saying. Kind of interpreting
I am a
what
machine,
you're trying to
that's why
say.
I talk to machine.
Yeah. And Chad,
So I started out just high level. Basically, I was doing unlock door, open door, enter car, closed door, and then for each one of those, I was breaking those apart for unlock car door, for example. Car key unlock is there's a driver's side door and passenger door. For that, you have car key unlock button press once, press button one time, unlocks driver's side. Car key unlock button press twice, unlocks all passenger side doors. And basically put away the key at that point. Then for open door, door handle, driver's side, grab handle, door handle, driver's side, pull up, basically pull up on handle, you have another one pull out, opening the door, and that point is just like,
Why'd you put away the key? You're going to use it here in like 20 seconds. You should have kept it out.
but what handle is the key in?
you look like
And for me,
you gotta
That is completely inefficient.
not for me, because I don't use the key to turn on the car. I push a button. So
I can see the
keys go on.
your action behavior, which is ultimately to be the function has a parameter on it. So that's kind of a little bit advanced. That the function can be customized. That's a good approach. Good job. And then Mike, please.
Yeah, so my first step was car.locate car. So you pass in what car you're looking for. Car key.retrieve, car key.unlock. And then with a if unlocked is not true, then car key.door.open or open. Car enter, car sit, car door close, car key ignition, verify car start, verify no warnings, resolve warning with a stop if certain warnings are found. If orientation street, gear drive. If orientation not street, I was working on that, but either gear reverse or stuff like that. While not at VGT, robot.drive with parameters for the with parameters for a direction set, and then robot.park, car key ignition off. That's where I start.
Okay, and you must a little bit more focusing on the if statement. If you said a lot of if there,
Yeah.
if isn't working, if is not working, verify something. If that's a good approach. That if something isn't happen, then you need to deal with the other condition that we need to handle that. So you have covered that. In that sense, you have a good job. And Andrew.
So pretty much what everybody else has generally been saying. I just went a little bit more detailed into the actions and the properties and made them all kind of like a class. So not exactly what you were looking for, but I had car key unlock.
Your class.
Say again?
Set up a class for this.
Pretty much.
Explain more about that.
Just like all of the actions and the properties that would could be changed by the actions, and yeah. So I had car key unlock action, a car key unlock button, which you had there, obviously, right? And then I had car door dot open action, car door dot close action, a car door dot outside handle and inside handle, and just kind of laid it out like that, and a method for me getting inside the car, getting outside of the car, steering wheel orientation, left or right, gear shifts, and what they should be in drive, reverse, park, gas pedal pressed or not pressed, brake pedal pressed or not pressed, signal oriented left or right, And see, mine was called carnavigate.work to go to work and carnavigate.home to go to home. So similar to what everybody else did with the robot to work, but
Good job, but yours are more like object oriented. You define the object in it and define its property, then its behavior under the object. So in that sense, you had a good job. I think that's gonna be much similar to our framework, which is fireworks.
okay.
Our fireworks consists of this kind of object. We call it a module. For example, like AMC module has a lot of properties and a lot of functions. It is properties and behavior. So in that module, we put in everything in there. Like we call it the AMC API. So you guys can use those attribute, which is a property, and the behavior, which is a function, very easily, just like you write it down there. Just call the function, and the machine, which is a task complete, is doing just what you need to do. That's what we have done so far for fireworks. It's going to be very easy for you to drive, just like you drive a car. When you automate it, just like a drive a car. Simple, huh? So here is the code. So you need to know the code. You need to understand the code in order to automate. So like here's the one of the code our.
I can't see the code.
So I popped up. Mike, can you interpret it?
Bar tab selected, search for. So it's searching for the WTPF control. If it exists, is enabled, is visible, then click. If that.
Okay, how do you feel about this? How do you feel about this?
The code?
Yeah.
Sure.
It's easy for you to understand this code or not? You need to know what search for WPF control, what that function do. We need to know what fetch swap tab control exists, fetch swap tab control selected, but whatever. You need to know everything about this. This is inside the car engine. You see the car engine inside. Are you feel comfortable? No, you're not. You're? You're?
Yeah.
Okay, then interpret it. Interpret it, please.
I don't know what your search for WPF control was. So it's the UI search for WPF control. You can pretty much read the same thing Mike read.
Okay. You are much more advanced.
Yeah.
Looking for a selected variable, and if it exists and it's enabled and it's visible, then you can click it. Fetch swap tab control, if it exists, and it's in SWAT apparently, select value and return true. Else false.
So you've got a combo box for.
Yeah. Even if you can interpret it, it takes a little bit more time, right? Unless we have a comment on there, right?
Yeah. I basically would have to see what I'm.
Yeah, you have to analyze what it is. You have to look into the function inside too to read this code. So readability of this code is very low. I can define that this code's readability is low. So then what about this? Eric, could you interpret that, please?
Sure. So it looks like you're just selecting a bunch of tabs, and if it's able to select them all, you're writing out that you sent a long pull with the game number and the code,
and then sending it. If you can do all those conditionals, it sends true, and then it logs. If it fails any of those, it logs out an error.
Also, part of it is it has the if something. If there isn't a value there, it triggers the else and then logs
Right.
the error.
Yeah. You know what I said?
Mm-hmm. So far, so good. Keep going on, please.
Is that all of it?
What's happening here?
Basically, you're
You mean like what tab you're using?
What's the result? If you run this, what happens?
It depends if you get all the way through.
Oh, assume the happy path first.
Okay, if you get all the way through, you're setting the game number. I'm not sure what tab it is in SWAT.
well, using SWAT, you're sending the 2F long poll for the
Right, but
game number.
I don't know what 2F long poll is. That's why I had no idea. It's just something to do with the game number.
Yes. Basically, you're getting into the tab.
You're using SWAT to set 2F, and then which is no 2F is meters. So you're getting the meters from SWAT through this.
Yeah,
Whatever.
so technically you don't even need to know what 2F is, you're just sending it.
Yeah.
And so you know that you sent it,
and you need to know what 2F is. Because if you don't, if
somebody
if I
else
some random
somebody
Joe,
else has already defined what 2F is,
Yeah.
all you're doing is sending
well,
it.
2F is defined in SAS.
No, and somebody else has already done the creating the module for 2F.
That's not what I'm saying. I'm saying if I don't know what 2F is in general in SAS, like what I didn't until I realized it was get meters, then I wouldn't know what this does. So when I looked at it, I was like, I don't know what 2F is. I thought we were setting the game, to be honest. But now, when I remember from years ago, that 2F just gets meters. It's the happy path is it goes in the swap, it puts in the game number, it sends it 2F, and it sets whatever meter code it wants, and then it gets it back.
And it logs out that message.
Yeah. And sets the return.
Mm-hmm. So simply put, it is sending the long pole. That's it. And verify if it's working fine or not. It's just kind of the behavior, just like you drive a car. The first line, select the manual test tab in the SWAT and go to the manual test tab and click it. That's it. If it doesn't click at all, due to some reasons, it goes to the else states, fail to select long pole. I mean, the fail to select the manual test tab is down there. You can see that. But the second thing is like select the long pole. There's a lot of long pole options on the drop down. So select the appropriate the long pole number and select it. If it isn't working fine, it goes to else statement and show the message of error there. And then like game number, you fill out the form under text box. The game number which is defined is up there. It keep deep inside and inside. The if nested loop shows that it goes to the deep inside to complete the test cases. So final thing inside is what? Click send button. So click send button and then it verifies if the send button is true, then it send and then verify. Oops. So so it has more readability. It's much easier to write the code. What you guys need to do is like know the API for each module of Fireworks. I will explain it to you later on how to use the each functions and attributes for each module. The next session. And the first code is kind of before Fireworks. The second code is after Fireworks. So the complicated thing has been encapsulated, and you just need to know just like you write the code here, the behavior oriented, easy to understand the name of the function. So currently we have this number of the APIs already, ready for use, period. The Gen 8 is the test console is right on progress. They are making it. So after that, we're gonna preparing for the API for the Gen 8 too soon. But right now, the SWOT, the device simulator, and task console, and the AMC module, those are ready. So, all in all, automation speaks for itself. Andrew, could you read the sentences below, please?
Yeah, sure. It will reduce the repetitious efforts, SAS test, regression test, etc. If there is a fireworks, you don't need to know complicated internal algorithm at all. Just like acquiring the driver license in order to drive a car, just learn how to write a code for verifying your Scrum team's product's quality.
Yeah. Kind of looks interesting, huh? Yeah. So you guys need to do is just learn how to use the APIs, which is already prepared, and just write the code. Andrew, finish reading this, please.
Okay. You are the automation liaison for respective Scrum team. Let's write the code and automate the test. Much closer gap between product development and quality assurance in each Scrum team.
So Andrew Sebastian is preparing this for like the gap between the verification, product development and verification get less and less. So that's what he's trying to do. So each of you are equipped with the automation technology. The goal for those strategy is going to be fulfilled, I believe. So next session is going to be we are looking to the fireworks more, module by module, and try to do a little bit of a lab, and try to write the code for the automation here.
Should they bring laptops?
Yeah, please.
Oh.
Any question? I think we time's up and 10 minutes more. If you have a question, if you have no question, and let's wrap it up for the today's session.
Yeah.
Thank you, guys.
Thank you.
Thank you, Alan.
So next time bring laptops. Anything that we need on the laptops?
If you don't have laptop, that's fine. I
No,
use
you
my.
can use on the laptop.
You're going to log into our Client 6 server there. Try to work on it. You don't have to install anything yet. Not yet.
Okay. You?
Cool.
Thank you.
Thanks for showing up, guys.
All right. Thank you.
Thank you, Andrew.
Bye.
Thank you. Thank you.